Assalamualaikum and hi, we are from Group FR, and in this video, we are going to talk about analysis of function 1 and analysis of function 2. Now let's start with the introductions. What is analysis of function? Functional analysis studies a function by investigating its behavior and identifying relationships and hypotheses that may arise. Analysis of function develop around the problem of solving equations with solution given by functions. The purpose of the analysis is to create a graph based on the function given. There are many methods of how to sketch a graph by using only a function such as finding the x and y intercepts, critical points, inflection points, and the intervals.
How do we differentiate between analysis of function 1 and analysis of function 2? Well, we often see the equation of analysis of function 2 are about rational functions, and for analysis of function 1, we often see the quadratic equations, so the graph might be different too.
Before we proceed to the solution of analysis of functions, let's take a look about the problem statement first. Given a function of fx equal to negative x divided by 1 minus x plus 4, A. Find the x-intercepts and y-intercepts if any. B. Find the vertical and horizontal asymptotes if any. C. Determine the intervals where fx is increasing or decreasing. D. Determine the intervals where fx is concave up or concave down. E. Find the inflection points if any. And lastly, using all the information, sketch the graph of fx using decimals.
So the first one, we need to find the x-intercept and y-intercept. For the x-intercept, y equals to 0. Substitute 0 into y. So the equation goes 0 equals to negative x over 1 minus x plus 4. Then we do the calculation until we get 4 over 5 for the x-intercept. Next, for the y-intercept, x equals to 0. Substitute 0 into x. So the equation goes f in the bracket is 0 equals to negative 0 over 1 minus 0 plus 4. Then we get the answer for the y-intercept. Next, we need to find the vertical and horizontal asymptotes. So the first one, we need to simplify the equation, which is fs equals to negative x over 1 minus x plus 4. After we simplify, we got the fs equals to 4 minus 5x over 1 minus x as the answer. Next, we need to find the vertical asymptotes. So let 1 minus x equals to 0. Then we got x equals to 1. Based on the answer we got just now, we need to use it. X equals to 1 to apply into the analysis of vertical asymptote. So lim fx, which is x approaching to 1 negative, is equals to 4 minus 5x over 1 minus x. Then we got negative infinity. Another one is lim fx, which is x approaching to 1 positive equals to 4 minus 5x over 1 minus x. Then we got positive infinity. Lastly, we need to find the horizontal asymptote. So lim fx, which is x approaching to positive infinity, equals to 4 minus 5x over 1 minus x. Then we completed the calculation until we got y equals to 5. For the next step, we need to determine the interval where fs is increasing or decreasing. So using the quotient rule formula, we substitute the value into formula until we got f prime x equals to negative 1 over 1 minus x squared. So the f prime is undefined, which is 1 minus x squared equals to 0. Then 1 minus x equals to 0, and lastly we got x equals to 1. For the interval negative infinity to 1 and 1 to positive infinity, with the sign of fs negative 1 over 1 minus x squared, we use 0 as the test value for negative infinity to 1. So we got negative. Then we use 2 as the test value for 1 to positive infinity. We got negative also. So the increasing interval is none and the decreasing interval is negative infinity to 1 union 1 to positive infinity.
Next, after find the first derivative, we move to the second derivative to find concave up and concave down. From the first derivative, negative x over 1 minus x squared, we arrange to negative 1 over x negative square. Next, we differentiate that and it became negative 2 over 1 minus 3x cubed. Next, let second derivative become 0. So, 1 minus x cubed equals to 0. Then, 1 over x equals to 0 and x became 1. Then, the interval is negative infinity to 1. And for the test value, we take number 0. From the 1 to infinity interval, we take a number 2. The sign calculate is negative 1 over 1 minus x cubed, and we got interval negative infinity to 1 is minus and 1 to infinity is positive. Therefore, 1 to infinity is concave up while negative infinity to 1 is concave down. Next, we calculate the inflection point. When x equal to 1, then insert in the equation of the question given. So it will be negative 1 over 1 minus bracket negative 1 plus 4. We got 0, it is undefined, hence no inflection exists. Lastly, we got the graph of rational function of the question given. Desmos is being used to find the graph. In this graph, we know that vertical asymptote is x equal to 1 and horizontal asymptote is y equals to 5.
Now, for the next questions. Given a function fx equal to negative x power of 3 plus 9x power of 2 minus 24x plus 2. A. Find the x and y intercepts if any. B. Find the first derivative of fx. C. Find the critical values and critical points. D. Construct the interval table. Find the interval where the graph of fx is increasing and decreasing. E. State the maximum point and minimum point. F. Find the second derivative of fx. G. Find the inflection value and state the inflection point if any. H. Find the interval where the graph of fx is concave up and concave down. And lastly, using all the information, sketch a graph of fx using Desmos.
First, we need to find the x and y intercept. X-intercept is negative x 3 square plus 9x square minus 24x plus 2 equal to 0.08608. For y-intercept is f equal to negative 0 3 square plus 90 square minus 24 plus 2 equals to 2. First derivative of fx. d per dx equal to negative x 3 square plus 9x square plus 24x plus 2 equals to negative d per dx x 3 square plus d per dx 9x square minus d per dx 24x plus d per dx 2. You must separate it and derivative it. So the final answer is negative 3x square plus 18x minus 24. Next, find the critical values and critical points. Negative 3x squared plus 18x negative 24 equals to 0. Factorize it and you will get x equal to 2 and x equal to 4. You must put the answer into the fx equation. F2 answer is negative 18 and F4 answer is negative 14. So, the critical point for the function fx equal to negative x 3 square plus 9x square minus 24x plus 2 are 2 negative 18 and 4 negative 14.
Next, find the interval where the graph of fx is increasing and decreasing. From the first derivative, negative x cubed plus 9x squared minus 24x plus 2, we differentiate that and it became negative 3x squared plus 18x minus 24. Insert the equation using the eqn, then we got x equals to 2 and x equal to 4. Then let second derivative became 0. So the interval is negative infinity to 2, and for the test value we take number 1. For the 2 to 4 interval we take number 3. For 4 to infinity interval, the test value we take is 5. The sign to calculate is f prime x equals to negative 3 square plus 18x minus 24. Hence, we got increasing interval is 2 to 4 is positive and 4 to infinity is negative. Hence, maximum point is 4, negative 14, while minimum point is 2, negative 18. Next, state the maximum point and minimum point. When x equals to 2, f2 equals to 2 cube plus 9 multiplied to 2 square minus 24 multiplied to plus 2. When y equals to 4, f4 equals to negative 4 cube plus 9 multiplied 4 square minus 24 multiplied to plus 2. We got negative 14. Hence, maximum point is 4, negative 14, while minimum point is 2, negative 18. Then, find the second derivative of fx, which is f prime x equals to negative 3x squared plus 18x minus 24. Then, double f prime x equals to negative 6x plus 18.
Find the inflection value and state the inflection point. First critical value is f prime equals to 0. We substitute the f prime into the equation, which is negative 6x plus 18 equal to 0. And then we solve it until you got the answer, which is x equal to 3. Then f3 equal to negative 3 squares plus 9 squares plus 24 plus 2 equals to negative 16. So the inflection point is 3, negative 16. Then find the interval where the graph of fx is concave up and concave down. So negative infinity 3 will have concave up graph, while 3 infinity will have concave down graph. Lastly, this is the graph. You can see the graph is concave up and concave down.
Before we end our video presentation for MAT183, we can conclude that we can determine the critical point as well as the x and y intercept by analyzing the function. Next, using the given fs, we can find the increasing and decreasing interval. Concave up and concave down can also be found by taking the second derivative from the given fx. The value of x that we obtain from the second derivative allows us to determine the inflection point. Finally, we can sketch the graph of fs using all the values obtained from using the first and second derivative.
That's all from us. I hope you guys get something out of watching our video and enjoy it very well. Goodbye!